Let's review the SOHCAHTOA. So I have this triangle with a measurement of sides of 3, 4, and 5. And this angle right here is x. So when I have SOHCAHTOA, I have sine, which is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. So in this case, sine of x equals 3 over 5. Cosine of x will be equal to 4 over 5. And tangent of x is equal to 3 over 4. What about the inverse functions? So the inverse functions in this case, it will be for sine, it would be cosecant x, which is 5 over 3. I'm just flipping the numbers here in the fraction, okay? And then the inverse function for cosine is secant, which is going to be 5 over 4. And the inverse function for tangent is cotangent. So it's 4 over 3. Now, actually, what does that mean exactly that they're inverse? It means that cosine of x actually equals to 1 over secant of x. What about sine of x? Sine of x will be equal to 1 over cosecant of x. And tangent of x equals to 1 over cotangent of x. Let's flip it now. So if I have secant of x, it's equal to 1 over cosecant of x. And then cosecant of x equals to 1 over sine of x. And then cotangent of x equals to 1 over tangent of x. So those are the inverse functions. But then I may have another scenario that is also called inverse, but I have cosine of x, and here I have a -1, and that's equal, let's say, 3 over 5. So in this case, it's really not the inverse function of cosine, but when you have that -1 right here in the exponent location, so it means that they're actually looking for the measurement of angle x. So please notice the difference.